Retrosynthetic analysis, Diels-Alder reaction. Let's now see how we can determine the reactants of a Diels-Alder reaction. Here is the Diels-Alder adduct. We call this an adduct because it's an addition product. Now first we are going to find out what are the newly formed bonds in the Diels-Alder adduct. So this is a sigma bond, this is a sigma bond, this is the pi bond. These are the bonds that are created during the Diels-Alder reaction. So we are going to break all of these three bonds. So now we are going to break these three bonds, okay, and we are going to put three new double bonds. This is the dienophile part of the molecule, and the other half would be a diene. And here are our reactants, the diene and the dienophile, which are required to synthesize this Diels-Alder adduct. So whenever you have the Diels-Alder product, find the cyclohexene molecule. Here is the cyclohexene molecule, and these should be the new sigma bonds, and this would be the pi bond. Let's go on to the next problem. Here we are going to give the numberings since we are dealing with a bridged bicyclic compound, and therefore it will be much easier for us. Okay, so let's find the cyclohexene framework. So here is our cyclohexene framework, and this carbon will be number 1, 2, 3, 4, and this is A and B. That's from the dienophile. Now let's find the three new bonds that are created in the Diels-Alder reaction. So this would be a bond, sigma bond, and this would be the pi bond. So these are the three bonds that we are going to break. So one, you can number this as carbon 5. This is 1, 2, 3, 4, and this is A and B. Now we already broke these bonds, and now we have to create three new double bonds. For that, we are going to put a double bond between carbon 2 and 1, so basically here, and between carbon 3 and 4, because since this is the new bond that is created, the diene should have two pi bonds to begin with, right? We're going to draw these two pi bonds, and also the dienophile should have a pi bond, right? And you can see from here, this is a 5-member ring structure. So this would be a 5-membered ring structure. This would be carbon 5, 1, 2, 3, 4. So we said that we are going to put a double bond between carbon 1 and 2. Let's do that. And there should also be double bond between carbon 3 and 4. And your dienophile has now been separated from the diene. So this would be carbon A and carbon B. There should be a double bond between carbon A and carbon B, right? And on carbon B, we do have a CH3 and CO2H. Okay, so these are the starting materials that you will be using to synthesize this Diels-Alder adduct.